Alright, this problem is yet another palindrome problem. So before I explain how to do this problem, I would highly recommend you guys solve this on your own. I'll provide the link to the problem in the description so you can try by yourself. So hopefully by now you've probably paused the video and tried to solve it by yourself. So right now I'll explain how I solve this problem. So this problem is essentially asking, given an array of numbers such as this, and we can remove any numbers from this array, but we want to have a palindrome. So for example, if I remove this one, this right here without B should be a palindrome. Now, originally, you guys might be thinking something like, that's really difficult, because there are many different possible combinations that you can remove the numbers, such as you can remove just A, you can remove just B, you can remove just A and B, and there's just way too many combinations for you to try, and ultimately this would just take too much time and is unreasonable to program. So there has to be another way to do this. So one thing that we have to know about palindromes is that, let's say we have a palindrome A, B, C, B, A. Now this right here would be a palindrome. However, if I remove the last two, BCB is also a palindrome. And if I remove the last two again, C is also a palindrome. So any palindrome, if we remove the last two, is also still a palindrome. And we know that this problem has a minimum length of 3 numbers to create a palindrome. So for example, we can have palindromes of length 2 or 1. So for this problem, it is essentially, let's look at another array right here. So let's say we have A, B, C, A. Now, one thing to note is that if I remove this one right here, then our palindrome is A, B, A, which, yes, is only 3 and is a palindrome. However, one thing to note is that this right here, B, the middle, can be anything. For example, this could be C, this could be D. In fact, we could remove this one and keep this C right here. It's still a palindrome. So then this question ultimately becomes, can we find in this array 2 elements that are the same but are not next to each other? Because we can have A dot 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 anything here and A. We know that we can always make a palindrome because we have these 2 letters right here, A, and we can remove any number of these inside here except for 1 to create a palindrome of length 3. So now our pseudocode is essentially go through each letter here, for example this, and then you have to skip the one right next to it because you know that it has to be more than 1 length away in order to have a number in the middle such that it is a palindrome. So we check, okay, is this the same as our starting position? No. Is this the same as our starting position? No. So then we go to the next one. Our start from here now comes to here, so we're at B, and we would go to here. And we would essentially keep on doing this. So then in the end, we essentially have 2 for loops where it is like for, and then essentially for the item in the list. And then we would have another for loop, which is the item plus 2. In array. And we can see here that our code will essentially take, we have this thing called big O notation, and big O notation essentially has like the maximum, usually it's like the maximum amount of time that our code will run in. So for this would like at the worst possible case scenario is that we don't have a palindrome in our thing at all. So this would take, we would do this n times for the number of items in the array, and then for this we would do this like n minus 2, n minus 3 as we progress along this for loop right here. So in the end, it would be something like n minus 2, then plus n minus 3, plus n minus 4. And this would be n times. So we would essentially have n squared minus a constant. And one thing in big O notation is that we usually just take the term with the highest degree, so this would be n squared, and because this constant is really small compared to a very large n, we would essentially kind of just remove this constant term. So in the end, we just have O of n squared, and that is the time that our program will take in the worst possible case scenario. So I'm going to link my code in the description below if you guys want to see how my code works, and thank you for watching this video on the CodeBakery.